Problem 1 is asking whether the relations that are shown are functions. So there's 3 different relations. This one is given as a map, which is very close to being a table. This one's a graph, and this one's an equation. So your job is to be able to look at these different forms of relations and tell whether or not they're functions. So the first thing you have to remember is that a function is a relation where every input has one and only one output. So we're looking here, and 3 has an output of -1. That's only 1. 0 has an output of 0. That's only 1. -3 has an output of 0. That's only 1. And -6 has an output of 2. So each input has only one output, which means the answer is yes. And it's your job to explain it in your own words or paraphrase the things that I said. Just as a note, if 0 also had an arrow going down here to number 2, we would have had to say no. Now, is this relationship below a function? So we have to remember that input is the x-axis, output is the y. So we want to look for a place where you put in an input, like say here at 1, and get 2 outputs. And sure enough, there's a place that happens. So here, this spot, no, there's only one output. Here, there's only one output. But when we get to here, there's 2 outputs for every input. So the answer is no. And you need to explain that in your own words. We didn't talk about this in the class, but this is called the, actually there's 3 outputs now that I'm looking here. 1, 2, 3. This is called the vertical line test, where when you draw a vertical line, you see if it touches more than once. And if it does, it doesn't pass. And now, is the relation below a function? And the best way to do that is to get your y by itself. So if I subtract x squared, I get y squared is equal to 16 minus x squared. And then I have to take a square root. But the thing is that whenever you take a square root, you have a positive and a negative output, positive and a negative. So when I do, that means that for every input, I could have 2 possible outputs. So again, the answer is no, and it's your job to explain that in words. Number 2, I'm going to go ahead and do on the same video, is the function below a linear function. So notice that these were relations, and your job was to prove that they were functions. But the wording of question 2, we know this is a function. For every input, there's only one output. But we want to know, is it a linear function? So to tell if it's a linear function, you have to look at a rate of change. So there's a couple ways you could do this. You could plot this in your stats in your calculator and look at the graph of it and see if it forms a straight line. The way I'm going to do it is to look at a rate of change. Now, I'm not noticing that there's any pattern to these numbers, but the problem is that there's also not a pattern to these when I'm just looking. So you have to go deeper. You actually really need to calculate the rate of change for each. So from 6 to 2 is going down by 4. This is going down by 9, and this is going down by 1. And then over here, we need to see if it's the same. This is going up by 1, this is going up by 3, and this is going up by 2. So we need to then see if the slope is the same. So the slope from here to here, the rate of change from the first 2 points is -4/1. The rate of change between these two is -9/3, which is the same thing as -3. And this is how we know already that the answer is no, and the reason is that it doesn't have a constant rate of change. So again, your job is to explain that in words that make sense to you.